Hey everybody, hopefully you're all having an awesome day today. Welcome back to my channel. This is WireDogSec. Before we get into it, be sure to hit that subscribe button, hit the like button, and comment below your thoughts and opinions. Share the video with friends, etc., etc. Today's video, we're going to go over Rustscan. Now, this is a free room inside of TryHackMe, so be sure to check it out if you haven't done so already or follow along with the video. Rustscan. Learn how to use Rustscan. Now, I have mentioned Rustscan in previous videos before, and basically it's like Nmap on crack. It says it's the modern day port scanner. I've only used it a handful of times, but we're going to go through and thoroughly discover what it can do, capabilities, all that good stuff. So maybe you can use this in your penetration testing career, in your cybersecurity career, what have you. Rustscan is the modern day port scanner capable of scanning targets in less than a second, extensible scripting language allowing you to write scripts in Python and much more. This room will teach you all there is to know about Rustscan. You can find Rustscan's GitHub repository here. It's got the link there, and that's all you need for that task. Task number 2, installing Rustscan. Installation procedure of Rustscan is very easy. If you use Mac OS, Arch, Docker, Nix OS, or any other operating system than Debian, more install instructions can be found on the repository. It's got a link there. Now, once you go to the Rustscan repo and install it on Kali Linux there, it gives you instructions on how to do so. So feel free to pause the video and go ahead and do that if you haven't done so already. I'm using the attack box on TryHackMe, so it's already installed as you already can tell. Now, moving on to task number 3. Rustscan is actively accessible. That means we use continuous integration testing to ensure accessibility needs are met. Manually test accessibility. This is important because accessibility is important in hacking. Hacking isn't just inaccessible, it is the opposite. It is actively excluding members from the community because of some issues they were born or developed that cannot help. It is a basic human right to extend everything we do to be accessible to everyone. In the same way, it is right for you to get healthcare, to get an education. Around 50% of all people suffer from some sort of disability. See this blog post for more information, so be sure to check out that blog post on why accessibility is important or the World Report on Disability for Statistics. For more information about accessibility and infosec, I wrote this blog post. So be sure to check it out if you haven't done so already. Now moving on to task number 4. Fast. Rustscan is fast, but why in short? Low-level kernel networking written in a fast language Rust. Asynchronous scanning. Multi-threading is slow due to the context switching cost. Async is fast. See my Rust room for more information about this. And this is an alternative to Nmap. It's apparently lightning fast compared to Nmap scans and such because it's using these various different features here. So it's got a lot of different advantages when it comes to Nmap. But learn Nmap as well in case you need to use that in your career. So it might be a good thing to learn both of these, Nmap and Rustscan. And on top of that, the Rust programming language, a lot of cyber criminals have moved their ransomware to Rust because it's fast. At its fastest settings, the bottleneck is not the program. The bottleneck is your computer, the network link between your computer and the target, and finally the target itself. If your OS/hardware isn't the best, that'll be the bottleneck. This sounds bad, but some other port scanners have their bottlenecks in the program itself. Rustscan is as fast as the system, the network, and the target is. Being so fast is bad, but Rustscan can be slowed down to however slow you want it. But just know if speed is your thing, Rustscan is where it's at. And I assume by being too fast, you could possibly overload a server or application or something and cause it to crash. How do you ensure speed? As more features are added into Rustscan, slowness tends to creep in unless noticed. As we add more features, the program generally tends to slow down. This is a rule for all programs. More complexity will often mean it is slower, but not always. Rustscan deals with this by manual testing on targets, continuous integration that fails if the program is too slow, benchmarking the program, and graphing the results. Keeping all features outside of the scanning itself, unless it's absolutely needed. Rustscan will not run code before or during the scan, only after. I have read this. Exactly, we just went over it. So let's move over to task number 5. Now for the largest feature of Rustscan, thanks to Burgaban, Burgaman for working on this one. Rustscan is extensible by the Rustscan scripting engine. This allows you to write a script which runs after the scan has completed, taking inputs of open ports and their respective IPs. RC supports these languages, Python, which is awesome. Be sure to check that out. I'm learning Python myself. Shell, Perl, any program which is binary and in the $path. Scripting engine arguments. Rustscan scripting engine can be altered using the dash dash scripts argument. There are three possible arguments. None. Don't run any scripts. Custom. Run all scripts in the scripts folder. Default. Run Nmap script or whatever script is in the config file. The default does not need to be enabled. It is on by default. Well, self-explanatory. Python custom scripts. To execute a custom script, we need a rustscan underscore scripts dot toml file located at the $home / dot rustscan underscore scripts dot toml. The script file should look like this, and it's got a little example there in case you want to create some script files yourself. Let's walk through this. Firstly, for reference, this is a basic Python script, and it shows you it in Python, or basic Python script that they're using here. The first line is always going to be a shebang, right, which is that right here, and it's telling you that it's using Python 3 for this script. Tags are categories of scripts. For example, we may have these categories: HTTP, SSH, Tomcat. I only wish to run scripts that match these categories. Our config file will only execute the scripts with the matching categories. Developer. This tag issues who the developer of the script is. Trigger point. This tag states at what port should the script trigger. For HTTP, it would be port 80. For HTTP and HTTPS, it would be 80, 443. Call format. Rustscan uses a templating library called text underscore placeholder. This allows us to enclose variables, and then it's got it listed out there. Doubly curly braces. Rustscan supports 3 variables: the script name, IP address, ports, and it's got another example here. The code itself, and everything after this metadata is the code itself. The script will receive arguments via sys.argv in the format specified in the call underscore format variable. Now with this data, we run the script, doing whatever we please, contributing, making scripts. We have a folder of examples and scripts here, so go ahead and check that out if you haven't done so already. It's on their GitHub. If you make a script, please consider contributing to Rustscan. Right now, you can submit a pull request to this folder and we'll include your script. Running other tools with Rustscan. Any tool installed in the system like Nmap, GoBus, etc. can be run with Rustscan. We do this by default with Nmap. To execute another program, create a shell script which calls that program. So to call Nmap, create a shell script with our Rustscan scripting engine, and then for the function, and it's got the information right there. You can replace this with GoBus or any program at all, so long as the program is installed and reachable in the $ path. What is the scripting file called? That's going to be rustscan underscore scripts.toml, as you saw above up here. One of the first things we read about right there. So there's the answer to that one. And to go back down, can you run other binaries in Rustscan? Yes, we can. It said we could run like Nmap and GoBus or other things in there. So that's going to be true. Does Rustscan support scripts in JavaScript? That's going to be false. So let's move on to task number 6. Rustscan is adaptive. That means it changes how it works to better suit its environment. We call this adaptive learning feature set. Some of these features included or are being worked on: adaptive outbound send, timing to optimize scanning. While Rustscan scans the target, it learns how it reacts, how fast is it to scan, does it respond quickly, how far away. By using data, Rustscan molds itself so it is the fastest scanner for any target. Custom top ports. Okay, I'm not going to read all this. Be sure to pause the video and check that out if you need to read all this. But basically, it's telling you how much faster it can be and how it does that, how it adapts to the scans, etc., etc. I think that's about it, or the gist of this section here. Scanning time. Task number 7. The tool is really amazing in terms of scanning. It can scan all the ports really fast and then pipe the output to Nmap. Now in this room, we'll scan our vulnerable machine. Basic format for Rustscan is Rustscan-R ports-A, and then you got target IP and map commands. Here's a full list of things you can do. Multiple IP scanning. So be sure to check this out if you haven't done so already. It explains all the options and stuff. Host scanning, Rustscan, how scan hosts like this. CIDR support, host files as input, individual ports scanning, multiple selected port scanning, ranges of ports, adjusting Nmap arguments, random port ordering. Try running the scan for all ports. So let's go ahead and do that. So let's get to scanning. We're going to scan all those ports. So it's going to be Rustscan -A for argument, and then your target IP --range for the port range. And you want all the ports. So it's going to be 1 to 65,535. Go ahead and launch that sucker. See what it does. And it's already telling you there's two open here. That's going to be ports 22 and port 80. So that's going to be answer here. Under 1,000 is going to be 2. Now it wants us to perform a version detection scan to discover the software running on port 22. Now how are we going to do that? Let's go ahead and clear this out. And I've already done that. So this is what mine looks like. Rustscan -A, target IP. The port's going to be 22. That's the one we want to target. And there's going to be -- to get into the Nmap arguments. And that's going to be SV for the version. So go ahead and launch that. See what it does. It's going to tell you the answer right here. Port 22 is open, and it's going to be open SSH 6.6.1P1, and that's going to be the answer here, this right here. And I already entered that in there. Now it wants us to do port 80 with an aggressive scan. So let's go ahead and clear this out and show you what I did here. This -A, Rustscan -A, and it's going to be the target IP. The port's going to be 80. That's the one that we want to target. -- to get into the Nmap argument, and then the argument for that Nmap scan for aggressive is going to be a --A. So go ahead and launch that. See what it does. See how lightning fast this is? I mean, this is just crazy. I wonder how fast this is on like the actual real world. Has anyone used this in the real world, like penetration testing or engagements or just on cybersecurity in general? Be sure to comment below. Okay, perform an aggressive scan. What flag isn't set under the results for port 80? And as you read through here, the scan results, you're going to scroll down and find that one flag that's not set, and that's going to be the HTTP only flag that's not set in here. After looking through the results, you're going to see it right here, HTTP only flag not set, right there. So let's continue on to task number 8. A short quiz on the more useful switches that we can use with Rustscan. All you'll need for this is the help menu for Rustscan. Include all parts of the switch unless otherwise specified. This includes dash. For example, we would specify the -Z switch via Rustscan -V. Okay, so let's go ahead and try that. Clear all this stuff out of here. And of course, to access the Rustscan help menu is going to be a -H option. With a lot of things, it's going to be -H or like --help or something like that. Let's go ahead and do that here. It's got the flags, stuff you can set here, -H or --help, like I said. Prints help information, that's going to answer this. Often referred to as quiet mode. Which switch can do this? It's going to be a -Q for quiet. Okay, for some reason -Q is not in here, but you can just guess it. -Q is for quiet mode. I mean, honestly, I went through these and just guessed what they are. So, but if you need to, go ahead and reference the help menu. Let's continue on to this next questioner. Which switch can help us to scan for a particular range? That's going to be the -R, right there, range. A range of ports with format start in. And we found that earlier when we went through this. What switch would you use to find out Rustscan's version? It's going to be -V for versions. Got it right there. Prints version information. Which switch will help us to select batch size? It's going to be a -B batch size there. And then the last one is which switch can set the timeout? That's going to be a -T. See there at the bottom here. Scroll down a bit. -T. All right, guys. If you enjoyed the video, the information shared, etc., be sure to hit that like button on the video. Helps out the channel. And then hit the subscribe button if you're not subscribed already. Comment below on your thoughts and opinions on the information shared. Have you used Rustscan before? Have you used it in the real world? Have you used it on CTFs? What's your thoughts on it? Be sure to comment below on that. And as always, thank you for watching. Have a good day.